In this video, we're going to look at the reflecting about the x-axis of the graph of the trig function. The first example, we consider y equals negative 2 times sine x from the point x equals 0 to x equals 2 pi. The base function is the function psi of x, as we use the 5 key points of the psi function. It's 0, 1, 0, negative 1, and 0 for an angle 0, pi over 2, pi, 3 pi over 2, and 2 pi, or in one cycle of the graph of the psi. To complete the table with the increment from 0 to 2 pi, the function based on y equals negative 2 times sine x, we can complete the table by the coefficient 2 multiplied by the value of the 5 key points at each one of them. The 5 key points that we listed on the upper right there, we place it with the value at the point 0, the value size is 0. At pi over 2, the value is 1, and then 0, negative 1, 0. Simplify the number to be 0, negative 2, 0, positive 2, and 0 for all 5 values. After that, we put together as an order pair form 0, 0, pi over 2, negative 2, pi, 0, 3 pi over 2, 2. The last one is 2 pi, 0. We make a list. The maximum value of the function is positive 2. The minimum value of the function is negative 2. Then we can make a list as the range of the graph is going to be the interval negative 2, positive 2. And the amplitude is a half of the absolute value of the max minus minimum value, or 1/2 times the absolute value of 2 minus negative 2, which is the value 4. Therefore, the amplitude is 2. From the graphing area, we're going to plot out the 5 points on it. So from this, let's see, we make the increment like from 0, pi over 2, pi, 3 pi over 2, and 2 pi. The maximum is positive 2. Minimum is negative 2. And next, we're going to locate all the other pairs on the graphing area. 0, 0, pi over 2, negative 2, pi, 0, 3 pi over 2, the value is 2, 2 pi, the value is 0, and connect all the dots or the points with a smooth curve. Okay, as you see, the amplitude is from subtracting the max and min and then divided by 2. Or another quick way to consider is the height of the graph from the midline of the graph to the top. And then the other one that we use as a property of the graph, the period. The period is the distance from the right end of the angle, 2 pi, and to the left, which is 0, that the graph complete one cycle. That means the graph return to the same function value and will repeat the same pattern after that. So the period is 2 pi. So we're gonna put the summary over here. So the period of the graph is 2 pi. Now we have the property of the graph as highlighted. The second example, we're gonna graph of the function y equals negative 1/2 times cosine x based on the cosine function. The 5 key points on the unit circle would be the point 1, 0, negative 1, 0, and back to 1. That is one cycle. And the angle starting from 0, pi over 2, pi, 3 pi over 2, and end up at the 2 pi. So for the 5 key points, we're going to use it to complete the table. The table, the increment of the x starting from 0 to 2 pi, the increment by pi over 2. So we have 5 points listed. the function y equals negative 1/2 times cosine x. And then after that, we're going to put them together in an order pair form. So what we have here, to compute the y value, the coefficient 1/2 multiplied by the value of the 5 key points at that angle. The 5 key points that we listed for the cosine value, cosine at 0 is 1, cosine at pi over 2 is 0, cosine at pi is negative 1, cosine at 3 pi over 2 is 0, and cosine at 2 pi is 1. And then just do the same routine, simplify the value. The first one is negative 1/2, the second one is 0, and next can be positive 1/2 becomes, and next can be 0. The last one is negative 1/2. As you see, the maximum value is 1/2. The minimum value is negative 1/2. Therefore, the range of the graph will be from negative 1/2 to positive 1/2. To compute the amplitude, it's from 1/2 multiplied by the max minus the minimum, which is 1/2 multiplied by 1/2 minus negative 1/2, or 1/2 multiplied by 1, and it turns out to be just 1/2. The period, we can look at the graph and then put together to find the period. So from the graph area here, we're going to make the increment of pi over 2. So 0 pi over 2, pi, 3 pi over 2, and 2 pi. The maximum is 1/2. Minimum is negative 1/2. Next, we're going to locate the coordinates on the graphing area. Oh, by the way, I forgot to put together as an order pair. So the first one, the order pair is 0, negative 1/2. Sorry about that. So pi over 2, comma 0, pi, comma 1/2, 3 pi over 2, comma 0. And the last one is 2 pi, comma negative 1/2. Then the first coordinate. So we have the order pair 0, comma negative 1/2. So going to be down here. At pi over 2, the function value is 0. At pi, the function value is 1/2. At 3 pi over 2, the function is 0. At 2 pi, the function value is negative 1/2. So the graph comes back to the same spot at the beginning point. So that means it completes the cycle at the point 2 pi. So we're gonna connect all 5 points with the smooth curve. And this is the graph of the function y equals negative 1/2 times cosine x. The period, as we see, is going to be the measurement from the right end of the cycle to the left end of the cycle. So the right end is 2 pi, the left end is 0. So the value of the period is 2 pi. So now we get the property of the graphs of y equals negative 1/2 times cosine x. In summary, the graphs of the function y equals a times sine x and a times cosine x will be reflected about the x-axis for a is less than 0. The amplitude will be the absolute value of the a, and the range would be from negative a to positive a. And we go back to the graph that we just did. So from the problem, for this one, the a is negative 2. So the amplitude is absolute value of the a, which is the absolute value of negative 2. The range is from negative absolute value of the a to positive absolute value of the a. Same as the graph of the cosine. For this one, the a equals negative 1/2. So the range is going to be from negative absolute value of the a to positive absolute value of the a. And the amplitude is the absolute value of the a, which is absolute value of negative 1/2 that returns positive 1/2. For these two graphs, as we see, a is less than 0.